Having right data ingestion framework and patterns are important consideration to have consistent data ready for analytics in timely manner, especially when you expect your data to grow every day. I'm Arshad Ali, and in this video, in the context of Azure Synapse Analytics SQL pool, I'm going to walk you through different data ingestion patterns and options available. In a traditional data warehousing system based on SMP architecture, typically you will have data ingestion pipeline based on ETL model, in which case the pipeline extracts the data from data sources, transforms it, and loads into data warehouse system. In this case, all the heavy lifting of data processing happens on a separate ETL machine before the final processed data is loaded into data warehousing system. It means your data warehouse database serves as a data store in most of the cases with limited processing in it. On the other hand, in modern data warehousing system, which is based on MPP architecture, typically you will have data ingestion pipeline based on ELT model, in which case the pipeline extracts the data from data sources, loads into a staging area of your database, and then runs transformation to process the data before loading processed data into final data warehouse model inside the same database. This way, you no longer need a separate powerful machine to do all the heavy lifting of data processing and can leverage the power of MPP for distributed parallel processing and to even scale it better as the demand grows for bigger and better storage and compute. I talked in detail about SMP versus MPP architecture in my previous video, but just to recap, as this concept is important for today's discussion, Synapse SQL is based on MPP architecture, in which there is a master node known as control node, and there are multiple worker nodes known as compute nodes. You can think of control node as brain and compute nodes as muscle of this computing cluster. With that, what I mean, an end user connects to control node and submits the query. The control node then creates a distributed query execution plan, sends that query execution plan to all the compute nodes inside this cluster, and each of the compute node processes the data that it has based on the execution plan that it has received from control node, and sends the data back to control node. Control node again aggregates all the results coming from all the compute node and sends it back to end user or the application. In this process, DMS or data movement service moves the data across between compute nodes if necessary during joins or group by, or between compute node and control node when compute node have processed the data and send it to control node to further aggregate and return to end user, or when you use data loading processes like BCP, bulk copy program to bulk load data, which goes through control node, and we'll have some examples of this data load process as well. On a high level, there are two approaches for data ingestion in Synapse SQL pool: single gated and parallel data load. In a single gated approach, a client connects to control node and start loading data in bulk. Then control nodes moves that data across all the compute node based on the distribution type that we have defined. This type of data load process applies to BCP, bulk copy program, which is a kind of command line utility to bulk load the data into SQL engine, and we'll see an example of that program and how it works. The program has API interface as well if you are doing the data load through your programming application or your application. That's called as SQL bulk copy API. That is something, another way to kind of load data in a single gated fashion. The one thing that you notice over here is even though the system itself is a distributed system, the data load process is kind of single gated. In this single gated approach, you can have multiple clients or multiple connections loading data simultaneously in parallel. While this approach might work for smaller data sets, It might not be right way for ingesting large volume of data as data moves through control node, and scaling out the cluster will not help much to optimize the data load performance. This is when you use parallel data load with technology or feature like Polybase and or the copy command. In this case, instead of data moving from clients to control node and then to compute node, the data movement is between the data source and compute node directly, and all this data movement is happening in parallel. This way you do not have a bottleneck on the control node side. That means scaling out your cluster or adding more compute nodes will optimize and improve the performance of your data load operation. This method of loading data parallelly applies to Polybase or copy command. That is something I'm going to demonstrate in this video. If you have been using SSIS packages or are using SSIS package, you can leverage latest Azure feature pack, which allows you to use Polybase from the SSIS package when loading data to SQL pool. Likewise, if you are using ADF, you can enable your pipeline to leverage either Polybase or copy command to ingest data parallelly. And this is what you can see on the screen, right? So this is one screenshot of ADF pipeline. And as you can see for the sink where the data is getting written to, the method of data load is mentioned over here. We can use Polybase, we can use copy command, or we can use bulk insert. So choice is with us, and based on our requirement we can pick any of this method to load data into the sink when we are using ADF pipeline. If you are a big data developer and write codes in Apache Spark in technologies like Synapse Spark Pool or Azure Databricks, you can use a Spark connector. This connector internally leverages Polybase and enables parallel data load. Polybase is a feature that accesses external data stored in Azure Blob Storage or Azure Data Lake Store via T-SQL language. Polybase enables data access outside database, in this case Azure Blob Storage or Azure Data Lake Store, using external table. You can think of an external table which only contains metadata used to describe external data and never holds data itself. It means when you drop an external table, it does not delete the data which is sitting outside the database. If you are coming from big data background, you can notice the behavior of an external table is very similar to Hive external table or unmanaged tables. Before we create an external table, we first need to create an external data source which encapsulates data source location details as well as the credentials to connect to it. We also need to create external file format which defines the format and the structure or actual layout of the data from the data source, like CSV, Parquet types of file, etc. And we will go through some practical examples later in this video. There are two types of external tables. Hadoop external tables, which leverages Hadoop API to access data, and the second type is native external tables, which are native to SQL pool and has additional functionalities. As of now, here is a list of feature difference between Hadoop external tables and native external table. The one thing that you would like to notice over here is when we talk about storage authentication, right? So through external table, we access the data sitting outside in the storage location. So how do we authenticate when we kind of access the data, right? So when it comes to Hadoop external table, the methods to authenticate connecting to a storage are use of access key, use of managed identity, use of individual user identity, Azure Active Directory identity. These are some of the methods to kind of connect to a storage account, get authenticated and access the data. The one thing which we do not have right now with Hadoop external table is use of shared access signature or shared access token to connect and get the data from the storage location. This feature is available with the native external table type. Once you have an external table created, you can leverage CTAS or create table as select a statement to load data into an internal table using the external table we just created. This operation is fully parallel operation. It means the more you scale your database, the better performance you can expect to have for data load operation. CTAS is very similar to select a star into command. However, it provides several flexibility. For example, you can use CTAS to recreate a table with different distribution type. If you have a round robin table, you can create a hash distributed table all in parallel to kind of have a different structure. In some cases, you might have a distribution on one column and you would find out that distribution is not optimal for your most of the query, and you would like to redistribute the data for that table on a different column. CTAS can help you in that kind of situation as well. The other type of situation where you can use CTAS is where you want to change the index type for a for your new table. For example, say if you have a table with cluster index and you want to create that table as column cluster index, you can do a CTAS of that data and create a new table with a new index type. This is the command that you see on the right side of this screen. We use create table and then we specify the name of the table, the target table that we want to create, and then we have with clause where we specify the type of index that we want to create on this table. In this case, I'm creating a heap table because it's a staging table just to temporarily store the data, and distribution type is round robin. And then we have as and the select statement from where we are selecting the data. So in this case, I am selecting the data from my external table to create an internal table and load data into an internal staging table. The way we can create CTAS statement to import data into the database, likewise there is a kind of another command to export the data out from database to a storage account or data lake store. And for that we have create external table as select statement or CETAS statement. This operation again is fully parallel operation, and this is one of the fastest way to export the result of a T-SQL query. In this example, as you can see on the screen on the right side, I'm running this command create external table and creating this external table with the name that I have specified over here, and then I'm specifying the details where I need to export this data to. So with location, I'm specifying the location on the data source where the data will be exported, and with the data source I'm specifying all the connection details to connect to the Azure storage or data lake store. With file format, I'm specifying the format of the file that will be created as part of the export, and then I have this select statement selecting the data from an internal table. So in this case, I have simple select statement from one single table, but that is not where it limits you. You can have in fact a complete query having joined with multiple tables, group by, and whatever you need it to be, and then you can take the output of that query and export it to the storage account. You can see another example here in this case. I'm joining these two tables, fact, internet sales, and dimension, customer dimension on customer key to see if there is any order placed by a given customer. If yes, then include that customer and export that data to my location that I have specified. After the create external table as select statement finishes, you can run transact SQL queries on this newly created external table. However, please note that because this external table is now based on exported data on the data source, in this case the storage location, querying this table will import the data into database for the duration of the query, unless you import this data again using CTAS statement. So every time when you are querying an external table, it needs to bring or read the data from a data lake store into like a temporary table to serve the query request, and then it has to drop, right? So if you are kind of trying to access this data multiple times, you might import that data back into database and run the query against that imported data multiple times. While Polybase is an optimal way to load data into SQL pool, it requires control database permission for creating master key, database scope credential, and external data source. And we'll talk about all these things as we go for examples. But know that creating these objects require control permission. Many of the times you might not be comfortable providing control database permission. Plus, many a times you would want a simplified way to load data parallelly with more flexibility than what is provided with Polybase. To cater to this need, Synapse team has come up with copy command functionality which provides better performance in many of the cases in a more simplistic way and provides the flexibility demanded. It copies the data from source to destination by retrieving the data from all the files from the folders and all its subfolders. It supports reading the data from Azure Data Lake Store as well as Azure Blob Store. The different types of formats supported are CSV, Parquet, ORC. And it supports reading the data from multiple location from the storage account. You can have comma separated location and it can pull the data from all those locations as specified. Some of the other flexibilities and functionalities copy command provides are, first of all, it does not require strict control database permission. It just requires a create table permission to create a table. The target table should be already available, so you need to have create table permission to create that table if the table is not available and you have to create it. If the table is already available, then you need insert into table permission and bulk operation permission. So basically the permission needed now is very limited in terms of what is needed with Polybase. You just need create table, insert into table, and bulk operation permission to run copy command. It does not require to create any additional database object, right? So if you remember, we talked about creating external table, but before we create an external table, we need to create external data source. We need to create external file format. Those are kind of dependency that we have with the Polybase. With copy command, we don't need to create those additional objects beforehand. With copy command, we can use a storage account using shared access signature token. No need to expose a storage account keys, and we'll look into the differences between a storage key versus shared access signature. It allows to use a different storage account for error file location. With Polybase, we can we can send all the dirty data to a different folder, but that folder needs to be on the same storage account. With copy command, you can have this dirty data going into a completely different storage account if there is any need. It also allows you to specify default value for each of the target column that you have in the table, as well as it allows you to do a source to target column mapping, right? So many a times, if the order of column in target is not same as the order of column in source file, your data load operation will fail. So copy command allows you to do the remapping of those columns, and we'll see an example of how we do that. And with that way, you'll not be having a pipeline that breaks in between during the data load process if there is any change in the order of the column. It supports multiple locations from the same storage account separated by comma, as we just discussed. With that, it's time to look at some practical examples. BCP or bulk copy program is an utility to bulk load the data from on your system to SQL Server instance, or in this case Azure Synapse SQL pool. The way we discussed earlier, the single get it approach, this bulk copy operation takes that approach to load data into a SQL pool database. I'm going to demonstrate how you can use BCP utility to bulk copies data from my local system to SQL pool database. But however, note that given this is single gated approach of data loading, you might consider using this approach only for a table or the data which is very small in size. If the data volume is large enough, you might consider using Polybase or copy command, which I'll discuss next, which has parallel data load operation. To start with, BCP requires the target table to be available already. So what I'm going to do here is I have connected to SQL pool database, and I'm going to create a table, in this case team date table, as an empty table. When I'll create it, it's going to be an empty table, and then I'll use bulk copy utility or BCP utility to bulk load data into this table from my local system. And this is going to be my final table. So I'm going to create a cluster index table on date key. I am not using cluster column store index on this table because this table is going to have only few thousand rows of data. And because this table is very small in size, I'm going to use distribution is equal to replicate. So basically this is going to be a replicated table. So with that, let me go ahead and run this command. Once we have the table created on the server, we need to ensure that BCP utility is installed on the local machine from where we want to load the data from. To do that, we can open a command prompt and we can type BCP -v. If the utility is already available, it's going to show me the version of the utility which is kind of installed currently. I have this version already available, so I'm good with the tool that is locally installed. Now next, what I'm going to do is show you the command which we use to load the data using BCP. So in this case, this is my command file. This is my batch file which I'm going to execute to load data into my SQL pool table. So I have set up a couple of variables. You can directly put this details into the command line itself. However, many of the times you might be loading data into multiple tables. So instead of redefining all these all these values, you can create variables and set the value to those variables. So in this case, I'm creating a server variable when I'm specifying the name of the server, Azure Synapse SQL pool server, user ID and password, and then the database, and then the schema. So these are my variables and all the declaration over here. Then finally, I'm defining a variable to define the location where I have the data file. Then I'm setting a variable to the name of the table which I'm going to load data into. And finally, I am going to execute the BCP command. And in this case, I have specified the name of the table, name of the target table in the form of a schema name dot table name. And then BCP utility can be used to import the data into an internal table or export the data out. In this case, because we want to insert the data or import the data into an internal table, we are using in as a keyword over here to insert the data in, and then we are specifying the file location where we have the data file available, name of the data file coming with this variable name, and this is a txt file. So this is my source data file from where I'll read all the data and load into the table that I just created. And then with -s, I'm specifying the name of the server to which I will be connecting while executing this command. This is the name of the database, and we specify the database with -d, small d, to point to that database. And then -u is to specify the user ID, and -p is the password which will be used to used to connect to that database, the username and password. And finally, there are different other parameters that you can specify with BCP. I'm going to include the link for the BCP utility in the description section that official documentation has all the details for the parameters that we can specify with BCP utility. For now, what I'm saying is my column delimiter is pipe. I have this file with pipe as a delimiter between two column values, and -r is basically the row terminator, right? So row terminator is new line character over here. -w is used for specifying that there are Unicode character in my files. So this is how you can define your batch file and run that batch file to load data into a SQL pool table. This is just for one table. You can have this multiple this command repeated for all your tables to which you want to load data into. This is one way to do that. However, in case if you have just to run data load for a single table, you can directly run this command on the command prompt itself instead of going through batch file. So I have this batch file created. Let me go ahead and execute that batch file on my command prompt, and to do that I'm going to say BCP, and this is the name of my batch file, BCP data load example.batch file, which has all the right configuration defined. If I execute this, you'll see that it has a started data load and it has loaded 1188 rows to the table that I just created. To validate, I can go to SSMS again, and this time I can query the table to see if the data has come into this table. And yes, indeed the data is here in this table. Next, I'm going to demonstrate Polybase, but before that, let me show you a couple of things. The very first thing is the storage account that I have, right? So you can install Microsoft Azure Storage Explorer, which gives you File Explorer experience of exploring the data that you have in the storage account, Azure storage account. So in this case, Trailblazers is my storage account, and even the container name is the same as my storage account. And if you see here, I have one folder, dim product, where I have multiple files with the data in it. So what I'm going to do is I'm going to run Polybase command to load data from this folder into an internal table or a staging table, and then I'll apply all sorts of transformation to load data into final data warehousing table, right? So this is one folder where I have a dim product data, source data. Likewise, I have another folder where I have the fact data for fact online sales. So these are two folders where I have the data to load data from. Apart from that, I would also like to show you the storage account in Azure portal, right? So if you go here into Azure portal and go to the storage account, in this case Trailblazer is my storage account, you'll see there are a couple of options over here, and the very first one that we want to kind of have a look at is the access key. If you click on this access key, this is how it's going to look like. So for now, the key for this storage account is kind of hidden here. You can click on this show key and it will show you the key which you can use to connect to this storage account. Anyone who wants to have access to this storage account, there are different ways you can provide access to this storage account, and the very first one is where you can give the access key to other person to kind of connect to this storage account and have all the permission or kind of access on this storage account. However, giving access key to anyone will have the person who has access to this access key, they'll have full control on your storage account, right? So you would not like everyone to have the complete control on your storage account. That's where shared access signature comes in play. So with shared access signature, you provide permission in a restricted fashion, right? So what you do with shared access signature is basically you specify the type of services that you would like the permission to be applied on, like blob, files, queue, or tables. Azure storage has different types of services under it, and these are all those services. Then what are the services resource type that you would like the permission to be applied on, and then what are the permission that you want to give to this token, right? So whether it's going to be only read access or read and write or delete, or list is basically to see the content, and all those things you can specify over here. And then you can specify the range of date, like what's the date range during which this shared access signature or token will be effective, right? With this definition, you can go ahead and generate a SAS token. This way you are giving the permission to, or when you share the SAS token to anyone, whoever has this access to SAS token, they'll be able to connect to blob storage account and will be able to perform the operation as defined over here during this time frame, that the window that we have set it, right? So this is one approach of kind of guaranteeing access to a storage account. In the first approach, basically like you are either sharing access key to have control or access on your storage account, or you are creating a shared access signature which has restrictive access and providing that shared access signature token to anyone who wants to have the access on your storage account and work on it. So this is one approach. The other approach is basically where you individually assign permission to each of the individual who wants to have access on your storage account. Basically, for example, I as an individual have one Azure ID created for myself, and if you want me to have access to your storage account, you can give me permission on my Azure Active Directory identity, right? So that's one way to kind of specify the permission. The other way is like if an application is connecting to a storage account, an application has an identity, a managed identity. You can provide access to a storage account using that managed identity for an application. So if an application is trying to connect to a storage account, they'll use the managed identity for that specific application, and based on the permission assigned to that managed identity, they'll be able to access the data from this storage account. So these are the two approaches. First is where you can share the access key or shared access signature, and the second approach is where you can have explicitly assign permission to either individual or group of individual, where like you say rollback access control, or you assign permission to manage identity for an application. With this information, let's go back to SSMS and start running some Polybase examples, right? So the very first thing that we have to create is the kind of dependent object even before we start creating the external table, right? So if you remember from our discussion from the slide, right? So we need to first create the file format, which defines the structure or the layout of the file, and then we have to create the external data source. To create file format, we use create external file format command, specify the name of the file format that we are creating over here, and then we with clause we specify the different parameter for to define the structure of the file that is there in the those data source, right? So in this case, I'm saying format type is equal to delimited text. This is basically the CSV file. The other options are to use Parquet, ORC or RC file. Then format options, with that we specify what's a field terminator. So 2 column values in the files are separated by pipe, and this is what I have specified over here. Next, I have specified a string delimiter. Next, I have a specified date format, right? So the data which is coming from the source, especially the fact data which is coming from the data source, this data have date, and this date have a specific format. So what's that format is something I have defined over here. And then next one is first row is equal to 1. It means it's going to read the data from the very first row. In many of the cases, you might have a data file coming in where you have first row as the header information. So when you are trying to load data from that file, you would like to kind of exclude the first row and start from the second row. So in that case, you can set this first row is equal to 2. So it's going to skip the header row and start from the second row. In my case, I do not have header row, so I'm going to start from the first row itself. And then your data file could be compressed, right? So based on the compression type that has been used to compress the data, you can use different data compression algorithm to uncompress the data before loading it. When data files are compressed, we transfer less data. However, there is a trade-off between transferring less data and increased CPU cycle needed to compress or decompress the data. Also, in many of the cases, the data compression algorithm are used which doesn't allow to split the file. So basically, the compressed file is non-splittable. It means like it's when it needs to be decompressed, it's going to be a single threaded operation. So in that case, you would like to have multiple files so that all data load from all these files can run in parallel. Now, how many number of files you should have is based on what's the performance level of your SQL pool. And there is a very good documentation, the official documentation, which talks about and provides a recommendation in terms of what's the ideal number of compressed file based on your performance level. Now we can execute this command to create this external file format. Let me execute this, and you'll notice this command has executed successfully. Next, once we have the file format created, we need to create the data source pointing to the Azure blob storage or data lake store where the data sits. In this case, I'm creating this with a create external data source command, and name of the data source here. Type is equal to Hadoop. In this case, the external tables are going to be Hadoop type, not the native one. Absence of type is equal to Hadoop means the external tables are going to be native ones. And then with location, I'm specifying the blob storage where I have the data sitting in, right? So in this case, this is my blob storage account, and this is the name of the container, right? So this is how you specify to create external data source, right? So what you see over here is we do not have any credential specified over here. So if there is no credential specified, SQL pool is going to use the credential of the individual who is executing this command to get it authenticated with a storage account, right? And when it fails, then it checks if the storage account has public access or like anyone has access to that storage account. If either of these two is true, you'll be able to access the data storage account. If not, your permission to access the data will be denied. So you should have as an individual access on that storage account, or the storage account should have public access to everyone, right? So in this case, I do not have anything. It means like it's going to be kind of public account. So let me execute this to create this external data source now. This is created. Usage of public storage account is limited to learning and training, or when we are working with public data set. In majority of the cases, you will have private storage account with all the security measure in place. And in that case, in order to connect to this private storage account, you need to be authenticated. You need the credential with all the details to get authenticated against this storage account. And once you have the access there, you'll be able to access data from this storage account. In order to create the credential to access this storage account, we can create a credential object, and to do that we use create database scope credential statement, and we specify the name of the credential that we are creating. And there are different ways we can create the credential to use with Polybase. And the very first one is where we kind of specify the storage account name and the storage account key, right? So this is one way to kind of define or create the credential to connect to storage account. As in this case, if you remember from our earlier discussion, because we are specifying the storage access key, this is going to give you the complete control on the storage account when you are accessing the data. So in majority of the cases, you would like to restrict that. I would like to use shared access signature, which has restrictive access on the storage account, right? So that is the first thing that we have to do. We need to kind of create the database scope credential. However, before we create that, we also need to kind of create a database master key, and for that we need to use create master key command. You can optionally use by password clause to specify a password to encrypt this master key, and this master key is further used to encrypt the sensitive information that you are specifying as part of the credential, right? So in this case, I have put the star just to kind of hide the storage key. But in actual, you'll have a storage key kind of specified when we are creating this credential object, and when that gets stored in the database, it needs to be encrypted, and this is where master key, database master key, comes in play to kind of encrypt that data before it gets stored into the database, right? So this is one way to kind of specify or create database scope credential. The other way is to use shared access signature. For that, you say identity is equal to shared access signature. So in this case, shared access signature is a constant string that we specify, and then we specify the token for the shared access signature that we created earlier in this demo. However, please note that this shared access signature is not going to work with Polybase external table. This will only work with native external table. So this is the second way to kind of access a storage account or private storage account. The third way is to kind of create a credential where you use manage identity. So managed identity is an identity of an application, right? So in this case, we have Synapse Workspace, and Synapse Workspace is an application. For this application to have an identity, we use managed identity for that application. So we kind of specifying the access to that managed identity to have access on the storage account, and when someone is executing this piece of code and using the managed identity, basically he or she is impersonating to use managed identity for the workspace to get authenticated when accessing the data from the storage location, right? So this is another way to kind of access the storage account. So in order for this managed identity to have access on a storage account, let me go back to a storage account that I have. And in this case, my storage account is Trailblazers. And if you come to the access control pane here on the left side, you'll see there is an option to check the permission assigned to any identity, whether it's an individual identity or managed identity. And I have this Trailblazers as one of the managed identity which has been assigned permission on this one. So if I click on this, you'll see this. You will see the permission that has been assigned to this managed identity, and you can see that this managed identity is part of a storage blob data contributor role, right? So anyone who needs access on the storage account needs to be part of a storage blob data contributor and a storage reader or a storage contributor role on the storage account. In this case, this is what we see. If you want to add additional storage account or you want to access additional storage account, you need to make sure whoever is accessing, whether it's an individual accessing the storage account or managed identity accessing the storage account, they have right permission to access the data from the storage account. Now let's go back to SQL Server Management Studio and create the database scope credential, and to do that we can come here and drop the existing one if it is already there and create a new database scope credential, right? So I have created this credential, AS credential workspace identity, and it's going to use manage identity of my Synapse workspace. With that, now we have created this credential. We can go ahead and create the external data source with the secure connection. In this case, this time I'm going to use again the same create external data source command and specify the name of the object that I'm creating over here, and type is going to be Hadoop, and then I'm specifying the location, right? So in this case, I'm saying this is the name of my storage account, this is the name of the container in that storage account that I'm going to access on. So with location I'm specifying those details, and then I'm saying credential is equal to the credential which I just created here in the previous command. So with that, let's go ahead and execute this command to create the external data source. One thing that you'll notice over here is there are multiple ways to specify the location, right? So in this case, when we are using manage identity, we have to use ABFSS kind of protocol or interface to kind of access the storage account, and then we have to specify DFS after the name of the storage account. So this is the one protocol that we have to use to kind of connect to the storage account. The legacy way or the old way of specifying the location is when we use WASP. This comes from the time when it was Windows Azure, then Microsoft Azure, which is now it's known as, right? So this is like Windows Azure storage blob, and S is the secure connection basically. And then after the name of the storage account, we have blob as a keyword to specify this is a blob storage account, right? So this way, if this doesn't work, you can use the other one, and with manage identity we have to specify ABFSS. Now as we have created external file format and external data source, we are all set to go ahead and create external table pointing to the location where we have the data files. We can run this command, create external table, specify the name of the external table that we are going to create, and then specify the structure of the data that's coming from the files, right? So here we can specify all the columns, their data types, nullability, and all those things we can specify over here. And at the end, with clause, we need to specify certain other parameters. So for example, in this case, we are saying data source is the data source we just created earlier with the credential object, and then we have dim product folder from where I want to read all the data when I'm querying this external table. And then I have also specified the file format, the one that we just created earlier. And in this case, the file format specifies that the data is in CSV format and the data is pipe delimited. The column values between different columns are delimited by pipe. And then you can also specify what happens when there is any failure, right? So when there is a dirty record, and dirty record is when you have mismatch in the data type for a given column value, or when you have different number of columns for a given row, right? So you were expecting 10 columns to be part of this part of the file, but you're getting say 8 column values in that file, right? So this is where we have the mismatch in the number of column value that's coming for a given row. So if that is the case, how it's going to treat those records? So in this case, those records are considered as dirty records, and you can set a location where those dirty records will be redirected to. So this location will have all the data files where we kind of encountered the dirty records, as well as the reason of why the process actually failed to load that data, right? So this is where we specify the location. Along with that, you can also specify a couple of other parameters to define how you are going to reject those dirty records. So in this case, my data is very sensitive and I want the process to fail even if there is only one failure. And to do that, I have the specified reject type is equal to value, and I specified the value as 1. Right, so the moment the load process encounters very first row as a dirty record, the process itself is going to fail. Right, the dirty record can be anywhere in the file, but the moment it hits one error, it's going to stop the processing there itself. In many of the cases, you might be tolerant if the data is not that critical, and you can set a higher value, right? So you can say, I'm fine with having 10 errors in the data load process as long as those data are getting kind of saved into reject directory for me to later analysis, and this way you can specify that, right? So this is where you can specify the number of rows that you are fine with having rejected before it starts failing the operation. And you can not only set the value in terms of the number of rows, you can also specify the percentage, right? So when you specify the percentage, the value, reject value is going to be anything between 0 to 100. When you specify the value, it's going to be applicable of number of rows failure in that case, which is kind of integer value. With that, let me go ahead and create this table. My table is created, and like other system views, we have system views for querying the information about external table. So we have sys.table system view, which has one column is underscore external. This indicates if the table is of internal table or external table, and if I query this, it's going to return me all the external table. And then we have specifically for external table, we have this sys.external tables system view. So let me run this and show you the result of this to query based on this catalog view. And in the first case, you can see that this is my table that was created. This is my user table. This was created on this date, modified on this date, and you will get all sorts of information related to this table. The other catalog view or system views provide the additional details about the external tables. In this case, if you notice here is it's giving us the detail about the location from where it's going to read the data files from. Then it's going to give us the information about the reject type, reject values, and all those things. And it's also going to give us the number of columns that the table has, right? So this is what you see as a maximum column ID used. So with that, we have created the table based on external data, and we can use that to extract the data from this data lake store and load into a staging table. To do that, we use CTAS statement. So in this case, create table and then specify the name of your target table. In this case, I want to load data into an internal staging table. And because it's a staging table, I'm creating this table as heap and distributing it on round robin fashion, right? And I'm selecting from the external table which I just created ever. If I go ahead and do that, it's going to give me a table, internal table, and load all the data into that table. At this point of time, if we go back to our ELT approach of data load, we extracted the data, loaded the data into a staging table. Now we can apply all sorts of transformation on the data from the staging table and load that final data into our data warehousing table, in this case the dimension table. And to do that, like, you can apply all sorts of transformation with the query that you can write over here, but just to explain it, I'm going to simply select the data from this staging table and insert that data, or kind of recreate a dimension table with the data that's coming from the staging table. In this case, because it's my final data warehousing table, I am going to use cluster column store index, considering the data volume is huge enough. If it is not, then you can continue to use cluster index on certain columns which are being used in querying, and then run this command. If I run this command, the data load goes from staging table to my main table. So this way you can load data from your staging table to the final table. This is the way to kind of import data into a SQL pool table. And as we talked earlier, we can also export the data out from an internal table to the data lake store. And to do that, we use create external table command, and in this case we specify the name of the external table that we are creating, and then at this time we use as select. So basically this command is the variation of CETAS statement we just used earlier. This is called as CETAS, where we say create external table as select, and in this case I'm selecting from the staging table that I have, and then I am kind of exporting that data out to this folder on my data lake storage, and then this is the data source that I'm going to use when I'm connecting to the storage account, and this is the file format that it will use to generate the file on. If I go ahead and run this command, you'll see my data has been exported into the data lake store, right? So this is the data that has been exported. At this time, this external table is just a pointer to the data in the data lake store in this folder. I can go ahead and drop this table, and it will not have any impact on the external table or the data that has been already exported. Also, every time when I'm querying this external table, the one that I just created with CETAS statement, it's going to read the data from blob storage to serve that query. So if you have frequent need of kind of querying the data, you might consider bringing the data into an internal table and write that command on the internal table data. So this is all about Polybase. With that, we can switch our gear and we can look at the copy command. Unlike Polybase, copy command expects the target table to be already created. That's number one. Number two is copy command doesn't require you to kind of create other objects like data source or file format. You can define all those parameters as part of the copy command statement itself. And then copy command does not need, or whoever is executing the copy command, they do not need to have control database permission to execute that command on. Let me show you some of the examples. So in this case, I'm going to recreate this staging team product table, and to do that, I'm going to drop the existing one with the data and recreate so that it's going to have no data. And again, because it's a staging table, I'm creating it as a heap and distributing it on a round robin fashion. So let me go ahead and execute this command. My table has been created or recreated basically, and this is the way to kind of load data into my staging table using the copy command. So what we specify over here is copy into. This is the keyword that we have to start with, and then we specify the name of the target table to which we want data to go into, and then we specify the location from where we are going to read the data from. In this case, this is my location, this is my storage account, and this is my container. This is the folder inside that container, and I'm going to read all the files within that folder with txt extension. So I'm saying a star.txt for that. This is one location that I have specified. You can specify multiple location also if you have data stored into multiple different folders, right? So this is to specify the location to read the data from. Next, with clause, you specify the different other parameters. In this case, my data is CSV, so I'm saying file type is equal to CSV. If you have Parquet, you can say Parquet. Next, I have field terminator. So the column values between different columns in the file is separated by pipe, and this is what I specify over here. Field quote is a string delimiter, in this case 0 length string that I have specified. First row is a kind of parameter to specify from where in the file you want to read the data from, right? So I want to read the data from the first row itself. If you have a header information, you would like to exclude that header information and start from row 2, you can set it to first row is equal to 2. And then you specify the credential. When you specify the credential, again we have multiple options here, including the use of shared access signature. So the very first option here is to kind of use a storage access key, and to do that you need to set identity is equal to a storage account key. So a storage account key is a constant that we have to write it over here. This doesn't change. And then you specify the storage access key over here, right? And with this configuration, it will be able to use that storage access key to connect to that storage account to read the data and load into this table. Next, you can specify the error file location where the error files will be redirected to in case of there is any dirty records coming into that file, right? So this is one way to kind of authenticate with the storage account access key and load data into the destination table. This is one way. The other way is, and this is what you'll be finding or doing in most of the cases when you will be using the copy command. In this case, we are authenticating with shared access signature. So we would not like to share storage access key to everyone who is kind of connecting to a storage account. We would like to have shared access signature and give it to people who are connecting to the storage account with restrictive access on certain type of services and certain type of permission assigned to them. In many of the cases, if the end users are just going to read the data, you would only get the read permission to read data from the file system. You would not like other people to write to your storage account, right? So in this case, the process is going to be pretty similar as the previous one. The only difference comes here when we specify the credential, right? So in this case, we say identity equal to shared access signature. So this is another constant that we have to specify when we are using shared access signature. And then we have to specify the token for SAS or shared access signature. This is the only difference. Rest other kind of piece of information will remain same, and then you can go ahead and execute this command to start loading the data with shared access signature. So that's the second way to kind of execute this copy command. The third way is to kind of use the managed identity. So managed identity of Synapse Workspace will be used to impersonate whoever is executing this command. That user will impersonate managed identity of Synapse Workspace to get authenticated with the storage account and start executing this piece of code. And to do that, we simply say identity equal to managed identity, right? So this way, managed identity of the workspace will be used to load data from the location that we have specified over here. And finally, the fourth option is where Active Directory user ID will be used to authenticate against, right? So in this case, if you see, we have we had credential in the previous command. In this case, we have omitted that. So absence of credential in this command indicates that the current user will be used to get authenticated against a storage account, right? So in this case, the credential pass through is happening, right? So whoever is executing that command, if that person is having access to the storage account, they'll be able to execute this command. Say for example, there is user A and user B. User A has access to the storage account. This is storage account. User B doesn't have access to this storage account. So if user A executes this command, his or her credential will be passed through to the storage account and will be authenticated and will be kind of allowed to read the data from this storage account. The same command, if is being executed by user 2, his or her credential will be passed to the storage account, and since that person doesn't have access on the storage account, this command will fail with the error message, right? So this is where like Azure AD account or identity pass-through process is happening for authenticating to the storage account. So let me go ahead. I as an individual have access to the storage account, and I want to use this way to kind of show you how the data loads happen. And I have connected to SQL pool using my own credential, Azure AD credential. So if I go ahead and execute this command, this is going to use my Azure AD pass-through to pull the data from storage account and load into my staging table. So now we have the data loaded in my staging table. We can go ahead and we can look at the data that is in my staging table. Right, so here is my data loaded with copy command. And if you notice, like, let me show you some of the other examples. So if you notice, we have this weight unit measure ID, and in many of the cases, if you notice, there are like some values, and there are few kind of rows where the value is null, right? So let me go ahead and execute this command. Let me say select a star from the staging table where weight unit measure ID is null, right? So if I execute this command, it's going to return me the list of rows where that column value is null, right? So this is my case. What I want to do next is basically when I'm loading the data, and if the value for this specific column is missing, I want to use the default value to kind of have this into my destination table, right? So this is where the kind of flexibility that copy command provides, and this is where we can use the column definition as part of the copy command. When we didn't specify the column mapping as part of the copy into command earlier, the command was able to map first column from source to first column of target, second column of source to second column of target. So that is how it actually mapped the source to target column. However, this copy command provides the flexibility where you can go and change the order of this mapping, right? And this could be a possibility where you have a table created and the order of the column is different from the order of the column in your source data file, right? If that is the case, you might go ahead and do this mapping change for you to customize your data load process. That's the flexibility that it provides. That's the one scenario. The other scenario is where you have this process already running, and for some reason the layout of your source data file has changed. So column, say there is a column which was on 5th position, now that column has moved to 10th position, right? So if that is the case, with this flexibility you can simply go ahead and redo the mapping. Your code will start working all fine, right? So that way you can change the source to target column mapping. In this case, if you see here, I'm specifying copy into and the name of the target table, and this is where I have specified all the column mapping. So this product key is my target column, and this is being mapped to the first column coming from the source data file. Product level is from my target table, and this is mapping to the second column from my data source file. Now consider product level is second column in my target table, but that column value is actually say fourth column in my source data file. So simply I can come here and I can change this to 4. So in this case, the fourth column from the source will be mapped to product level and the data will be inserted over here, right? So this is how you can change the column mapping. Along with that, you can also change the default for a given column, right? So we wanted to change weight unit measure ID, and we wanted to kind of have default as ounces whenever there is a null into that column, right? So we can say this is my target column and I want to have default as ounce, and this column value maps to 18 column from the data source file that I have, right? So this is how you can define the column mapping. So let me go ahead and kind of drop the existing table again and recreate it with no data, and then I will load this again. If I go ahead, I'm going to recreate this table, this blank table, right? And the table is recreated. I can go back again here. This is my copy command, and this time I'm doing the column mapping is explicitly as part of this command, and rest other pieces of information will remain, say the one that you see over here, and I'm going to execute this. So basically it's going to put the default value wherever it finds null into weight unit measure ID column. And if I come here and run the same command, the one that we ran earlier, to see if there is any null value, this time we'll see there is no null value, and this is what you see. And if we go here, we can look at the data where we have all the data correctly mapped, and the column weight unit measure ID has no null value. So basically wherever we had null value, that has been mapped with default ounces, and there is no null value now. So this way you can either use Polybase or copy command to load data into your staging table, and from there you can apply all sorts of transformation to load data into your target destination table, which is kind of data warehousing table, dimension or fact tables. If you are kind of recreating the table, you can use CETAS statement to load data into your target table or recreate that table with a new fresh set of data. But in many of the cases, you might have data already loaded. For example, in incremental data refresh scenario, where you have the data already loaded and you have incremental data coming in which you want to load into the table that you have already with some data. To do that, like, you can use kind of insert a statement or update a statement, or the newly introduced merge statement to merge the data into your target table based on the incremental or data that has just come in. That's one way to do that. But if your data volume, the change of data volume is good enough or large enough, you might consider recreating that table with CTAS statement every time. In many of the cases, you will see that use of CTAS statements has better performance than running individually insert operation or update operation. And that is because of the overhead involved with the cluster column store index and how it works, right? To do that, or to incrementally refresh the data into a table which is already having data, what we can do here is we can create a CTAS statement again, and this time I'm going to create a CTAS. I'm going to create an intermediate table with the data, and the very first select a statement is going to read all the existing rows from my current table. So this is my final current table, basically the dimension table, and I'm selecting all the record from my existing table, and then I'm selecting all the record from my staging table. So this is going to give me all the new rows, this is going to give me all my existing rows, and I'm doing a union all to recreate this intermediate table, right? So this table, once created, will have both existing rows as well as the new rows, right? This CTAS statements assumes that all the incoming rows are new rows only, which might not be the case always. There might be a situation where you have some updates also coming in. To take care of that scenario, you can rewrite the CTAS statement slightly differently. So in this case, what I'm doing is I'm creating this intermediate table again with CTAS statement, and then I'm selecting from the staging table to get all the new rows or new version of the rows which have been updated, right? So I'm selecting those rows from the staging table. When I'm going to select the data from my existing table, right, I'm going to only select the data which has not been impacted. Basically all the rows which are not getting updated in most recent execution or in my staging table. So I'm going to say where not exist and select from the staging table by mapping the product key. If there is a record or product key in my staging table and the same record also exists in my destination table, it means a staging record has most up-to-date information, and I can exclude that from my second part of the query, right? So this query is going to give us only rows that has not been updated, the existing record which has not been updated, whereas the first part of the query is going to give you all the new rows and all the updated rows. So this way we can create an intermediate table with the fresh set of data which is most up to date at this point in time, and then you can go ahead and rename the existing dimension table to something different, right? So in this case I'm saying cso.dim product, rename it to product underscore old, right? So this is where I'm kind of renaming that table to a different name, and then the intermediate table that I created earlier with the fresh set of data, I'm renaming that table to the name of the table that my original table had. So this way you can have incremental data refresh by using CTAS statement. To sum up, while we have insert, update, delete, or even merge a statement to kind of merge data into our destination table, in many of the cases you might use CTAS to kind of refresh the data in your destination table, especially for the fact tables. I showed it here, an example for dimension table. But in many of the cases, your fact tables where the large volume of data is changing, you might consider using the CTAS to refresh the data into your into your fact table. That's going to be most optimal way to refresh the data. You can do quick test in your scenario to see what works best for you, whether it's going to be a mix of insert, update, which works best for you for your specific table, or whether CTAS is going to work faster, and based on your scenario you can pick the right solution for yourself. Finally, we can look at monitoring aspect of data load process, right? So in this case, what I'm going to do is I am going to create an external table, right? Fact online sales. My earlier table is a dimension table which has very small data set. So I'm going to create an external table for the fact online sales data and load some data and show you how you can how you can monitor the progress of this data load operation. So for that, let me go ahead and create this external table first. So this external table is created, and the way we defined the parameters earlier or different settings earlier for the external table, this is going to be same. The only difference here is the location. I have changed the location to point to fact online sales folder where we have the fact online sales data. Now I'm going to use this external table to load data into my staging table, and my staging table is going to be heap, and distribution is going to be round robin. So this is one way where I'm loading data into heap. The other way is like I'm reading the data and loading into my final destination table, which has cluster column store index, right? Given we have large volume of data, and distribution is on a particular column of the table, which makes the query performance optimal, right? So typically you will have ELT operation. You'll extract the data, load into a staging, and load into your final table with all the transformation applied to it, right? But for the sake of explaining the concept, let me kind of go ahead and run this command where I'm selecting from the external table and loading directly into my fact table, the final fact table, which has cluster, column, store, index, and distribution on a given column. Right, so if I execute this command, I'm going to execute this command on this connection, and in the next connection I'm going to monitor how this command is actually executing and how data is moving. Right, to do that, let me execute this command here on this connection, go to the other window with other command and run this query to get the currently executing query. This is going to give me the query ID which is currently executing, and you see this was the running state at that point of time. Now because the data volume is not that huge, the query has finished executing now, but we are looking for this query ID. Let me take this query ID from here and then go here and place this query ID into this monitor how data load has progressed. Right, so I place this and I'm going to execute all the code in this window, and I'll explain you what it's doing. But let me kind of execute this, and you will notice that there are multiple results that coming in here because we have multiple selector statement as part of this execution. The very first one is something that we would like to look at is this one, right? So let's say compute, and you see this, it's saying create table, and it's creating the table with data into it, and it's giving us the minimum duration and the maximum duration and average duration for this step of the distributed execution of the query, and total duration it has taken to execute that step as part of this execution. Then finally, because this table is a cluster, column, store, index table, it's showing us another step to create cluster, column, store, index, and again we have the same information, the min duration, max duration, average duration, and total duration that has taken to kind of execute that step. In the second part or second result of this query, you can see that there are 20 files. Let me go here. There are 20 files that have been read, and you can see these files, right? And these 20 files have been read in parallel by 2 compute nodes which I have in this database, right? So the performance level for my database is 1000 DWC. So with that 1000 DWC, we have 2 compute node, and you can see there is one compute node with node ID 15. There is another compute node with node ID 14, right? And half of the data was processed by one, another half was processed by the second one, and all this processing happened in parallel. So if you see the start time, it's going to be almost same for all the data load operation, right? And this indicates that when we are using Polybase or copy command, the data load operation is all going to be parallel, and it's going to be from data source to compute node. It doesn't need to go it doesn't go through the control node at all, right? So this is how the data load process actually happens, and data moves from these files to the table that we are creating, and this indicates the bytes, the number of bytes processed from each of the file. And finally, the third query, let me bring it here, shows that how much data was written to each of the distribution that we have for the table, right? So we know that each table that we create in Synapse SQL pool, there are 60 distribution, right? So given this is a distributed on hash column product key, how was the distribution and how much data was written into each of those distribution? You can see this with row processed column over here, right? So what we see over here is the distribution ID. In this case 31 has this many rows processed and stored in that one, on that distribution. 32 has like almost 167,000 rows processed and stored in that distribution, right? So this is another query which gives you an information about how the data load operation actually happened when you were kind of reading from data source, writing into the destination table. how many files were read, how many rows were processed from each of those files and loaded into each of those 60 distribution. This is how you can monitor the execution of your query. Thank you once again for watching. I hope this video was helpful and you learned something new today. Please do like, subscribe, and let me know your feedback or any specific topic you'd like me to cover next. In my next video, I'm going to talk in detail about multi-layer security architecture available with Azure Synapse and how you can build modern data warehouse system with confidence in Azure Synapse. Stay tuned.